This video is focusing on sequences. A sequence is an ordered set of numbers, and the way that appears is that it would look like a list of numbers. So a number, comma, sort of like this or this. Within each sequence, the numbers are considered to be terms. You can either have an infinite sequence, which means that it's a list that continues forever or without end. And then you can have a finite sequence, which just has a limited number of terms. For example, an infinite sequence would be the set of all integers. That ... means it's going to keep on going forever and ever and ever. But here you can see that this has a set of 4 different terms. So that would be a finite sequence. Let's take a look at this example here. Once again, this is a finite sequence and this is an infinite sequence because there's the ... meaning it's going to continue. The domain refers to the place or the position. So when I'm looking at it, I have a domain of 1, 2, 3, 4, 5. So that means there's 5 terms. Typically we start at 1 unless I specify for you to start at a different number, which is possible. And the range is the actual term or the terms of the sequence. So this would have a domain of 1, meaning the first position, and a range of 3. In the second position, it has a domain of 2 and a range of 6, so on and so forth. So all of that was just some vocabulary before we actually begin trying different examples. What we're going to do in example 1 is we're going to write the terms of sequences. All you have to do is use the rule that I give you to find the first 6 terms. So what we do is we would find a sub 1 because it's a sub n. N is the number or the domain. So a sub 1 would give me the first position, and I plug in a 1 wherever I see n. So that would be 2 times 1 plus 3. I'm just going to keep writing the rules. A sub 2 is going to be 2 times 2 plus 3. A sub 3 will be 2 times 3 plus 3. A sub 4 is 2 times 4 plus 3. A sub 5 is 2 times 5 plus 3, and a sub 6 is 2 times 6 plus 3. So now all we have to do, once writing the rules, is actually solve for it. 2 times 1 is 2, plus 3, that's going to give me 5. 2 times 2 is 4, plus 3 will give me 7. And then at some point, you don't have to write this step each time. So here I have 2 times 3, which is 6, plus 3 would be 9. 2 times 4 is 8, plus 3 is 11. 2 times 5 is 10, plus 3 is 13. And then 2 times 6 is 12, plus 3, that's going to give me 15. Now we do have to write our final answer as a sequence. So my final answer will be in the first position, I need to put the 5. A sub 2 is 7, so the second position is 7, and just keep going. 9, 11, 13, 15. Now that's the first 6 numbers, but technically I could have kept plugging more in it, so we could write this as an infinite sequence, which is where I put a comma and ... Next, we are going to find the first 6 terms for -2 raised to the n minus 1 power. This is the same process, just a little bit different in the way we write it. So it's f of n. So the first term is f of 1, where we plug in a 1 wherever we see an n. Well, that would give me -2 to the 1 minus 1 power. That equals -2 to the 0 power. When we were learning properties of exponents earlier in the year, we learned that anything to the 0 power is 1. F of 2 is -2 to the 2 minus 1 power. Let's clean up the exponent. 2 minus 1 is 1, so we really have negative 2 to the first power, or negative 2. F of 3 is negative 2 to the 3 minus 1, or negative 2 being squared. Whenever you raise it to a square, keep in mind that something times itself. Negative 2 times a negative 2 is a positive 4. So far we can see we have positive, negative, positive. That means our next term is probably going to be negative. F of 4 is negative 2 to the 4 minus 1, or that's negative 2 cubed. Negative 2 times itself 3 times, so negative 2 times negative 2 is a positive 4, times negative 2 is a negative 8. Okay, just 2 more. F of 5, which is equivalent to negative 2 to the 4th power. Because it's an even power, I know it's going to be positive. So that's going to be negative 2 times negative 2 times negative 2 times negative 2. Or, really, it's negative 8 times negative 2, because this was cubed. So negative 8 times a negative 2 is a positive 16. Last one, we need to find f of 6. That's negative 2 to the 6 minus 1, or negative 2 to the 5th power. So, because it's to an odd power, I know that the exponent is going to be, or excuse me, because it's an odd exponent, I know that the solution is going to be negative. So that's going to be a negative 16 times 2, which should be 32. And I need to write my final answer as an infinite sequence. Not only that, it's an infinite alternating sequence is what we call that. Oh, sorry, I didn't realize you couldn't see. We call it an alternating sequence because it's alternating in signs. So that's just some more vocab for you. C and D look a little bit different. For this one, it gives you the starting one. So we already have a sub 1. And we're going to use this to find the other terms. So if I have a sub 1, a sub 2 is going to be a sub n minus 1 minus 8, or a sub 2 minus 1 minus 8, or a sub 1 minus 8. Really, when you see this, I want you to think to use the previous term. So for a sub 2, I'm going to do a sub 1 minus 8. So negative 5 minus 8. And that'll give me negative 13. A sub 3, you're going to use the a sub 2 and subtract 8. So we have negative 13 minus 8. And when you subtract a number from a negative number, it becomes a larger negative number. So that's negative 21. Okay. A sub 4 uses a sub 3, so negative 21 minus 8. That's negative 29. A sub 5, same thing. We're going to use the negative 21, or excuse me, the negative 29, the previous term, and subtract 8 from that. And that would give you a negative 37. Last one. Once again, use the previous term. We have negative 37. We're going to subtract 8 from it. You could write that out, or at this point, you could just start writing the solution. That's going to be, here, I'll write it out. Negative 37 minus 8 is negative 45. And then write your answer as a sequence, wherever there's room. Here, I'll write it this way. Negative 13, negative 21, negative 29, negative 37, negative 45, dot, dot, dot. All right, D, we have the a sub 1 given to us, and now we're going to multiply the previous term by negative 3. So real quick, a sub 2, we do negative 3 times the previous term, so a sub 1 was 2. That gives me a negative 6. Okay, a sub 3 is a negative 3 times the previous term. So the previous term of a sub 3 is a sub 2. So negative 6 was the last solution I got. That gives me a positive 18. A sub 4 is going to be negative 3 times the previous term. So times that a sub 3, which was 18. And that would give me negative 54. Okay. A sub 5 is negative 3 times a sub 4, which was negative 54. Two negatives we know will give us a positive, so it's positive 162. A sub 6 is negative 3 times the previous, so a sub 5, which is 162. Because it's a negative and a positive, we know it's going to be a negative 486. And you know what? I just noticed when I was about to write my sequence, I forgot to put the a sub 1 in my last one. Good thing I caught that. So that's negative 5, comma, negative 13, negative 21. And this one's going to be, my a sub 1 was 2, negative 6, 18, negative 54, 162, and negative 486, dot, dot, dot. I'd like you to pause the video and try the bottom two. Pause the video and check your answers to try number 1. Pause the video and check your answers to try number 2. We are now going to use the relationship between the domain and the range to write a general rule for the sequences that we see here. So it's always helpful if you write your domain underneath the terms. This is the first position, so it has a domain of 1. Second has 2, third is 3, fourth is 4. I'm going to do the same thing over here. 1, 2, 3, 4. So I gave you 4 terms to help you recognize the pattern. Whenever we write a rule, it's a sub n equals. So that's the start of our rule, just like how we do f of x equals something. When I look at these terms, I notice it goes negative, positive, negative, positive. So when that happens, it will be negative 1 to the n power or n plus 1. If you start with a negative, we want to make sure when I plug in n, it gives me a negative number. So if it's negative 1 to the first power, that does give me a negative. If I would have had n plus 1 here, let's say, that's negative 1 to the n plus 1, or 1 plus 1, which is 2. Well, negative 1 squared is a positive 1, and we wouldn't want that. So again, your options here when you have an alternating sequence is to use negative 1 to the n power or negative 1 to the n plus 1. Now, when I look at each term, you see how there's a 1 in every single numerator? I'm going to put times 1 over, because it's always going to be a 1. And then I ask, how do I get from 1 to a 3? From a 2 to a 9? 3 to a 27, a 4 to an 81. What do you have to do in order to get that? And I happen to recognize that would be 3 to the power of n, 3 to the power of your domain. Because 3 to the first power is 3, 3 squared is 9, 3 cubed is 27, and 3 to the fourth power is 81. If you take a look at B, we have a sub n equals, it is not an alternating sequence, so I do not have to put the negative 1n. I just need to look for a pattern. So what do I have to do to the domain in order to get the range? Well, I notice that 1 times 2 gives me 2. 2 times 3 gives me 6. 3 times 4 is 12. 4 times 5 is 20. So my pattern that I see is n times n plus 1. Pause the video and try the try problems. Please check your answers. Hopefully these were a little bit easier. If you have any questions, write a private comment or see me in class. I would like you to begin the homework at this time.